Today, let's discuss a deck of cards. So, if you guys don't know what a deck of cards is, or you've never seen up close what they contain, basically it has 52 cards in total. You have 4 face cards, which are the spades, the diamond, the hearts. Oh, what was this called? Oh, I forgot its name. But again, you've seen the shape. And each one of these has the following: ace, the numbers 2 through 10, and the jack, the queen, and the king. So each one of them has all these, making it a total of 52. Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 13 for each one of these. And so 13 times 4, do the math, that will be 52. So with that in mind, let's look at the first probability. What is the probability that we have a black card? Well, first of all, how many of these face cards are black? Half of them. So if we have 52 cards and half of them are black, well, what's going to be the probability? Well, what's 52 divided by 2? That would be 26. Out of how many? The total cost was 52. Can we reduce this, guys? Yes, we can. Divide by 2 on both. So we get 13 over. What's 52 divided by 2? 26. Can I reduce more? Yeah, you guessed it, because since it's half, you're basically talking about 1 over 2, right? Now, what is the probability that we get a king? How many kings do we have in this deck of cards? Remember, each face card has 1 king. So if we have 4 face cards, that will be 4 out of 52. Can we reduce by 4, guys? What's 4 divided by 4? It's 1. What's 52 divided by 4? It's 13. 1 out of 13 is a probability. And what is a probability of getting an ace or an 8? Now, this is a tricky one because we have or. I want either one of these to happen. So, aces. We have 1 ace, and in every face card, we have 4 face cards. So, for the aces, it's 4 out of 52. How many 8s do we have? We have 1 for every face card. So, once again, it's another 4 out of 52. And because I want either one to happen, I want to add these probabilities because I want either one of them to happen to me. So I don't care about getting both at the same time, just either one. So that will make it a total of 8 out of 52. And if I were to reduce, guys, what's 8 divided by 4? I think 4 is the biggest number I can divide by. That will be a 2. What's 52 divided by 4? Divided by 4, that will be a 13. So that's my probability for number 3. And number 4, what's the probability of getting a hearts? Well, remember, hearts is one of the face cards, and we have 4 face cards, so it'll be 1 out of 4. That's simple. Oh, this is a good one. What is the probability of getting 3 queens with replacement? What does that mean? That means basically you have the 52 cards, and you want to grab one randomly. What is the odds that the first one is a queen? You put the card back in the deck of cards. Your second pick is going to be a queen. You put it back. And the third one's going to be a queen. Well, how many queens do we have, first of all? We have 1 queen per face cards. And there's 4 face cards. So that'll be 4 out of 52 times. And then that'll be your first try. Try number 1. And that's the probability. And then your try number 2, you still have 4 queens out of 52. And your third try, because you're putting it back, you still have 4 queens out of 52. So let's multiply these, guys. What's 4 times 4 times 4? That will be 64 over. Now here's where it gets crazy. 52 times 52 times 52. That's 140,608. And if you try to make this into a percent, guys, let's see what's going to happen. What's 64 divided by 140,608? We get 0.000455. Multiply by 100 to turn it into a percent. Times 100, you get. So your percentage will be 0.0455%. So notice the odds of this happening is very small because, again, there's a lot of cards and you want it to happen 3 times in a row. It's kind of crazy. So there you have it. Now, my favorite one is this one, this little challenge. What is the probability of getting 3 kings without replacement? In this case, you don't want to put the card back. So in my first try, you would get Again, there's 4 kings available out of 52 cards. But now what's going to happen in your second try? Let's say it happened the first try. You're not going to put that king back because it's without replacement. So now there's only 3 kings left. But since you took a card away, it'll be out of 51, right? And let's pretend that still happened. Well, in your third try, now you're only going to have 2 kings because you're not putting them back in the deck of cards. And now you only have 50 cards. Well, what's going to happen if you were to multiply these and figure it out? Well, what's 4 times 3 times 2? That would be a 24. Out of what's 52 times 51 times 50? That's 137,904. Now, let's see how this is going to look as a percent. Divide 24 by 137,904. That will be 0.000174 times 100 to make it into a percent. So that's actually going to be 0.0174%. So a lot smaller. Look, that was 0.4. Now that's 0.1. A lot smaller because you're taking away those cards. But again, the odds of these two happening are super small. And that's basically probability with a deck of cards.